So So I just wanted to get it straight. So the topic is going to be our journeyman exam prep course for the next 12 weeks, correct? Or longer.
Or longer. It'll be master and journeyman exam prep. Because
Okay.
I'm gonna go through a lot of really good calculations.
I'm gonna be a master one day, but not today. I have to go with David Engelhart. Go Blue! I'll have to give a big Go Blue shout out to my brother. My brother's a big Michigan fan, so
I think Michigan. I think they're probably gonna win. They got a good team. So
yeah,
I agree. But Washington's had a better team than I thought they did. I didn't think there's no way in hell they were beating Texas.
Yeah,
but I was wrong. I'll say one thing: their quarterback's good. God dang, he's good.
Yeah.
So
yeah.
All right, let's get it going.
It's all good.
All right. Now, the first thing that's going to happen, we're just going to look at applying some AC/DC formulas. And what I'm going to do here is I'm going to go through all the different formulas and everything with an example problem. And then what's going to happen is I'm going to go to the next one, which is going to be an exercise page. And what I'm going to do is I'm going to let it set up there for about 15 seconds. And anybody that wants to watch the video, you'll have like homework, I guess. And you can go grab a piece of paper and I'll show you here in a little bit. You'll have A, B, C, D, and you'll go in and work the problem. And then next week when I come back, I'll give the answers on that, and then I'll get the next setup for the next lesson. We'll go through all the example calculation, and the next week we'll have the exercise problem and go over it again. Okay. So
hey, I have a question though.
Mm-hmm.
So is there a way we could set up like a stupid question for like the end? Like everybody could just have their own stupid question for like the end of it. Like my stupid question I always think about is, what's the difference between kilowatts and kilovolt amps?
Sure, we can do that. If you want to ask that, then I'll put it at.
Yeah, like when you're all done with your lesson, whatever. Yeah, whatever. It'll just be like everyone's entitled to have like their own stupid question, and they don't have to all be stupid, but just some question that they want to ask, And
okay, yeah, we can do that.
That'd be cool.
Okay, now as you look at your AC/DC formulas, you got some certain letters that are used, and when you look at those, they mean something. So anytime you see I, we know that's amps. Anytime you see E is volts or V is volts. PF is power factor, KW is kilowatts, KVA is kilovolt amps, HP is horsepower, and EFF is efficiency. Those are the terms we need to know when we're looking at applying AC/DC formulas. Okay? So when you come in and you look at this is just a basic thing that we put together. It's in our publications. And basically we tell you what type of calculation is, where it's direct current or alternating current. And then you come over to the left-hand side and we'll tell you what is it you're looking for here. Okay? And then you come across, and based on whether it's direct current or you have a 120 volt circuit, you have a 208, 230, 240 volt, or anything that's three phases above. These are the calculations that you're going to use. Now, anybody that goes through any type of apprenticeship or anything, these are formulas you need to learn. And the reason we always start with this is because when you get into some of the examinations, they're going to make you calculate and find some of this information, knowing how to apply these type of formulas. Okay,
True.
and then you'll get your question. As long as you knew how to calculate using these formulas, you're not going to have a problem. So,
Yeah, I actually enjoyed when I took my last test for the NISAT 2, just off of the way you explain this. It was just, you were really confident when you do your calculations.
sure,
Because you know that it is, whatever answer you have, you know it's the right answer. You don't even have to second guess it.
sure, and you can tell by just the things they're asking. Like here, uh, we know the horsepower's known. Okay, so we got 40 horsepower here. It's 460 volts. It's a three-phase induction motor. And then look, they're telling you I've got a power factor of 90%, and then I have a operating efficiency of 85%. Okay, now what I always like to teach here on this is first you want to take the horsepower and multiply it by 746 watts per each watt. That's what you're going to use. Is the the uh, the number 746. Now, after that, everything's going to divide into that. So then you know you got 460 volt. It's three phase. So for three phase, we use 1.732, and then you've got 85% efficiency, 90% power factor. You're going to multiply all that together, and that's going to give
Right.
you 609.5 volts. And then you take the 40 horsepower times 746 watts, and that's going to give you 29,840 VA. And then you just take the voltage, divide it into the VA, and it's going to tell you the amps are 48.9 amps when the horsepower is known. And the horsepower will include what? That power factor and operating efficiency. It's pretty simple. And when I've been teaching for a long time, and I actually went out. I was doing a class out at Pantex out in Amarillo. That's where they do ammunition and stuff for the government. And they wanted me just to come out there and go over these calculations and explain them. And they even had their engineers in there to make sure they knew the proper amperage ratings when they were applying any type of new installations, because they were always adding stuff out there. Okay.
Right.
Now, the next thing you're going to look at.
Juan has one for a stupid question. Full load amps versus full load current. So.
Okay, I'll cover those two next week. All right.
Yeah.
I do them right now, but there's so much to do.
Yeah, just do your thing. I just want to make like a stupid question thing. Like anybody could ask their stupid question, we'll cover them.
No worries. All right. Now, when you get to this, I'm not going to cover this right now because I'm going to let everybody go back and work this. But you're going to notice we're going to give you known values that are in here. So you've got a 5 horsepower motor. It's 230 volts. You got 80% efficiency and 90% power factor. It's a 230 volt single phase. The only difference in this one than the other calculation is it wasn't three phase, so I didn't have to put the 1.732 on there. Okay?
Right.
Just giving everybody to get them used to this. And what you're going to do is you can go back, look at this, and all you're going to do is you'll see right there on the right-hand side where it says exercise problem, and you've got all the way to J. You just put A, B, C, D, put your answer in. Next week you come here, we'll see if you got it right. And if there's something you didn't understand, then you ask me a question on it. Okay?
I like it.
I gave this a lot of thought, and I thought I could just go ahead and give them everything. Then I thought, it might be good to let them be able to work the problems and then come back and look at them. And this way, it's sort of like a classroom instruction, if that makes sense.
Yeah.
So.
Yeah. No, I love the way you do it. It made me way more confident when I went to take my test, just because I knew that when I had the right answer, I mean, I was smashing it. I was like sitting there, oh, yep, right, correct.
Sure.
And that's the whole reason I made the Nat King Code page, was to make sure you guys are confident in your, taking this test. Like, you're going to go in there, you're going to pass. There's not an option of fail.
Well, and I think people come in, they listen to to this podcast, they're hearing easy ways to do things. And like, here's another, this is where the kilowatts now. So I got 54 kW load. Now let's look at what we have. It's 240 volt single phase. And look, they have a 75% power factor. Well, like I said, we're going to put it in VA form or watts, whatever you want to call it. So you take the 54 kW times 1,000, and then everything else goes over there and multiplies again. So you take the 240 volt, I had 75% power factor, that gives me 180 volts. Divide that in to what we calculated first, just taking the load, and that'll give you 300 amps. Now, the reason I like looking at this, because this was not hard. If you notice, the first one we did, we got all the VA form, then everything else was to the right, wasn't it? And it all multiplied together. Okay? And a lot of people get confused a lot of times. Where do I put this value? Where do I put this value? Just come over, take your load, get it in VA form, watts, whatever, and then you're going to divide whatever's left, and you'll multiply all that together to divide into it, and that's going to give you your amps. Okay?
Yep.
So when you come over and you look at this, and same calculation, there's only one difference. We did it in three phase. So now if it's in three phase, we're adding the 1.732. And in step 2, we gave you the formula there. And then if you look in the middle, we got formula requirements, and you can see all the different formula requirements that could be there, that could apply to that calculation. So if I didn't have power factor there, then it'd just be the voltage, wouldn't it?
Yes,
see that? That's what you're looking at here, is going through and getting used to these formula requirements. And I can tell you, I've seen a lot of publications out there and think none of them are set up like this. These type of illustrations took us, I'm just telling you, it takes a lot of time to develop these type of illustrations and all these fill in the blanks and stuff. Okay.
Well, yeah, I mean, you had to get that outlet in there on the left hand side.
Yeah. We're going to find out about that. Okay, now look at this, and this is where we know the kilovolt amps. Now, if you look, I don't have any power factor, I don't have any efficiency or anything. It's just 240 volts. So I'm going to take the load at 1,000, 72,000. Then everything that's left goes on the right side to divide it by, which the only thing I have is 240 volts. Divide that 240 volts into 72,000 VA, and you got 300 amps. Okay? And then when you come and look at this, the only thing that changed in this calculation is it's a three phase. So you'll notice in step 2, we got the formula there to sort of get you used to this. We're giving you two different options here to look at applying when you're doing this type of calculation. So the first one, we didn't have three phase. This one, in the exercise problem, we do have three phase. Okay?
Right.
Now, this one, I'm going to look at getting the kilovolt amp rating. Now, this is a little different because I'm trying, instead of coming back like I was the other, I'm trying to get to a rating. Okay? So in other words, I'm looking for the kilovolt amps where I have a 300 amp load supplied by a single phase 240 volt system with a 75% power factor. Well, the only thing you're going to do here is take everything, multiply it together just like you did, but the only thing you're going to do is divide it by 1,000, and that'll give you your KVA. I did exactly the same thing I did a while ago. The only difference here is I'm trying to get a KVA rating, and I divide it by 1,000. Okay?
Right.
Everything else was still multiplied together. All right? And then when you get over here, you got the exact same thing. The only difference is it's a three-phase system. And if it's a three-phase, you're going to have to put the 1.732 in there for the multiplication part, then divide it, or multiply all that together and then divide it by 1,000. Okay? And if anybody's getting confused on where to find the information, just look over here in the known values, and then you can work these problems and know where we're getting these different values from. All right? Now, looky here. Now I want to find the kilovolt amp rating. Okay? I got 300 amps load, 240 volt single phase. Just multiply everything together and divide it by what? 1,000.
Yeah.
Okay. What I'm trying to
And
point out, I'm not changing anything here. It's just what am I trying to find and how do I go about that calculation? But the main part I like to point out is you're still taking them loads, voltages, power factor, efficiency, and everything and multiplying it all together. And you're either dividing into the watts or VA, or you're dividing 1,000 into it to find the load for kilowatts, amps, or whatever you're looking for.
yeah, and one thing I want to bring up, James, and you kind of taught me this when we first started kind of going through this about our when we did the 100 foot rule about the 1,000 foot uh, multiplier, and
Mm-hmm.
I really enjoyed that. That it taught me a lot because when we just so everyone knows when we first started talking about this, James had a thumb rule saying if you have to go over 100 foot, then you have to include voltage drop because when they first made the ampacity table, it's based on 1,000 foot.
It was, and
And
it was burning conductors up. They realized they had
yeah,
a mistake. And actually, if you go back and look in the American Standards Handbook, and we might do that uh, uh, after we get through all this, and I'll go through all of that again. But where
okay,
we went in and we actually show where they would go in and they would say for like a number 14, once you got to like 65 foot or something, they wanted you to start looking at doing voltage drop. But
correct.
the difference was when they put that in like that, that was for solid conductors. Now that you have the stranded, now it's just a rule of thumb. You want to start looking at that at 100 foot.
True.
Okay.
Yeah, I really like that, but that was just a little added extra thing where it comes to the 1,000
Sure. And
multiplier.
and then when you get in, look in here, same calculation. Once again, we did the first one with single phase and the exercise. This is a exercise problem, and we're telling you it's three phase, so you need to take it at 1.732. So one of the things that we've tried to do through our publications, if you'll notice, we're showing you and highlighting in the middle there the formula you want to use for this calculation. Okay.
Sure.
So we're trying to help you out every way we can so you know what you're looking for and how to get that information. Now,
Yeah.
this one is a little bit different because what I'm going to do is find what is my horsepower rating. Well, the same thing applies. You take the 460 volt, the three phase, you take the power factor at 90%, and you take the the efficiency of the motor, which is 85%, and then you take what is it pulling? It's pulling 48.98 amps. Okay. Now, what you're going to do is you're going to take all of that, multiply it, and then since we're trying to get the horsepower, what is 1 watt good for? 746. So you're not dividing by 1,000, you're doing it by a watt. So you're going to take that 746, divide it into it, and it's going to tell you it pulls 41 or you have to have a horsepower rating of 41.7 horsepower.
Okay.
And this is a rule of thumb. The way that when the guys were out in the field a long time ago, they used to do this all the time. And anybody that listened to the podcast, we might get him to do it again. Dad did on the motors, and he was going in talking about the rule of thumb, how they would go in size the horsepower rating, and then he would look at doing the overcurrent protection device. He would tell you a rule of thumb, you take it at 300%, 200%. He went
Right.
through all of that and showed you and it was based on the frame type of the motor is the reason they did it that way. So,
Oh yeah, tempo.
all right. And then when you get
Yeah,
here,
yeah, Juan. We'll check it out. We'll see.
oh yeah, I
We
have
always
him as a
love.
guest. I just go in there and slap him, tell him to come in here and get to work.
There you go. I like it.
Say, oh man, you got work to do.
Yeah.
Now,
All right.
same calculation here. All I'm doing is finding the value for the horsepower, and the only difference here is it's a single phase where the other was a three phase, and I had to take it at 1.732. So what we're doing, we're going back and forth in different ones because we want you to be able to see there's different ways to calculate this. Okay.
Right.
Now, let's say you looked at this and it didn't have a power factor. The only thing is, it'd still be the same calculation. You just leave off the power factor. You still divide it by 746 per watt, don't you? Okay. Now,
Yeah.
that takes care of your AC DC formulas. And that's about as
Right.
easy as I can explain it. Is just remember everything is taken, multiplied together, and depending on what you're doing, if say like you're finding the kilovolt amps, then you divide by 1,000. Okay.
Right.
But if my kilovolt amps and everything's not known, then I'm going to divide by the voltage and everything and get the kVA and take it at 1,000 and divide into it. Okay. So
Nice.
it just sort of depends the calculation you're doing. And I think everybody understands that pretty well now.
Yeah,
Now,
and that's awesome. Like I like that little illustration you have there. That's pretty cool.
well,
I've
we
never
have
seen that before.
we have this comes out of the design book, and it's also in the Journeyman, it's also in the Masters, and it's also in the generator transform motor compressor. And the reason it's in there is because a lot of times when you're doing these different things, you got to know Ohm's law, pi formulas, and all of that are where they're combined. Okay. And when I was going through school, this was taught to me. Basically, if you take your finger, put it over E, which is the voltage, then you multiply what the amperage and resistance is. If I put my
Right.
finger over R, then you divide the amperage into the voltage. If I put my finger over the I divide the resistance into the voltage. That is basic calculations for Ohm's law. And then we'll get into pi formulas here in just a little bit. Okay?
Yeah, and it's basically like it's almost kind of like a triangle. So if there's anything that is unknown, then you have those two knowns that you could use to find the unknown.
Sure. It,
So I
it,
like that.
it's very simple once you understand the concepts. And then I'm going to show you something when we get over and you've got the power combined with everything. So we're going to look at something a little different, and we're actually going to have a wheel for the power, for the voltage, for the amperage and resistance. And each one of those will have three different calculations for it. And we'll take a look at that.
Okay.
Now, it says, what is the load in a circuit where a current amperage of 4 amps and a resistance ohms of 30 ohms? Now, like I said, you just put your finger over the E, and what do you get? You get I time R, and you take the 4 amps times 30 ohms. That's going to give you 120 volts. It's pretty simple. Okay? And you're going to notice we're going to use a lot of the same values as y'all go through this. And then when you get over here, you got the exact same thing. Now you'll notice we took right in there and we put the little wheel there, and you'll see we got it in green for finding the voltage, and then everything else is left and white to try to make it as simple as possible. Then we give you a basic circuit there showing you what the amperage and resistance is, and then you're going to multiply those together to determine your voltage. Now, when I get over here and I'm looking at finding the amperage, I put my finger over that I, and that means the resistance is divided into what? The voltage. I got 120
Correct.
volts and I got 30 ohms. I'll take 30 ohms divided into 120 volts, and that's going to give me 4 amps. Pretty simple. Okay. And if
Okay.
you look, while ago we had 4 amps and 30 ohms. Okay. So I'm
Yeah.
keeping the same thing here. Now, when you get to this one here, you're going to have exactly the same values that were in that other illustration. And you'll notice once again, we got the current in green, and then you'll see the voltage is above the resistance in the wheel. So you're going to divide the resistance into the voltage to determine what the amperage rating is. Then when I go to the resistance, I got 120 volts again. I got 4 amps of current. So I take the 4 amps divided into the 120 volts, and it gives you what? 30 ohms. Okay. So
Yeah,
all,
and I like this how people can go back and you could see like on the right hand side how there's all these little boxes that you could fill out, and you could actually do these calculations just so everyone knows that you can actually do these calculations and prove that James is not gonna win the Willie quiz tonight. Oh,
You
gotcha.
never know.
Yeah.
I got 1 or 3 last week. Those were all guesses. They'll probably be all guesses this week.
Well, no, I try to make it a lot easier this week because I know that you're a good guesser. So.
All right. And then this one, same thing. You'll notice we got the will R. So you got the voltage above the current. So the current's divided into the voltage and determine what your ohm rating is. Now, you're going to notice, and this is what's great the way we did this, because you can go back to the illustrations or you can go back to the example problems we did and see the exact same values were used, and we still got the exact same values that we started with. Okay.
Right.
So that's why we did it this way. So, I've seen a lot of publications, they do all different types, values and stuff. We tried to keep all of ours the same. So when you go back and look, you can go, yeah, I get it.
Looks like Juan has something to tell you. He normally lets the guys he mentors single phase, straightforward, 3-phase, requires a square root of 3, which is
1.7. Some put 1.73, some put 1.732.
Yeah.
We do 1.732.
Oh, David remembers the first day of his apprenticeship. The instructor told us that we were going to learn about ear.
That's what we are going to do, and we'll, after we get through all of this, and I'm going to do the voltage drop calculations, and I'm going to show it where you have a single phase, and I'm going to do one for branch circuit feeder. Then we're going to do a 3-phase and add the 0.866 on there. Okay.
Nice. Sweet.
Now this is pi formulas. Look, it's the exact same concept. Okay. If you're looking for the power and you put your finger over P, I time E. Okay. If I put my finger on I, E is divided into the power. If I put it over E, I is divided into P. Okay.
Yeah.
So these are pi formulas. Now let's look. We're going to keep it the same. You got 240 volts and you got an amperage of 40 amps. Okay. It tells me there, put my finger over at P at E time I. So 240 volts times 40 amps gives me 9,600 watts. Pretty simple. Okay. Yeah. Same thing here. You'll see we got the power. There's my will there. I time E. We even highlight in the formula requirements there what the formula is. And you're just going to multiply them together to determine what the watts is. Okay. Now, I'm going to look for the amperage here. So I got 9,600 watts and 240 volts. P is over E. So that means I'm going to divide the volts into the wattage. So I've got 9,600 watts, which I just calculated. Divide it by 240 volts, and it gives me 40 amps. So just like I did, the 40 amps times 240 volts gave me 9,600 watts. Okay. And then if you look here, we're going to use the same values again. There's your I, P over E, divide the E into the P, and that is going to give you, once you know the values, it's going to tell you what your amp rating is. Okay. Now I'm going to find the voltage. Put my hand over P, or my hand over E, and I'm going to divide the amperage into the wattage. So I got 9,600 watts. I got 40 amps, divide that into it, and guess what I get? 240 volts. Now, it didn't matter if I was doing Ohm's law or I'm doing pi formulas here. One is E-I-R, the other is P-I-E. Depending on which one, you just take your thumb. This is how you go about looking at performing this calculation. And then once again, here's my will. P is over I, so I'm going to divide the current into the power. Once I know those values, I'll make that calculation, and that'll tell you what the voltage is. Now, up to this point, I don't think anybody should have any problems under this. This is the basics, okay, of learning how to apply this. Now, what's going to happen here is where I'm going to get into the will of everything. And I'm going to show you some different things here that we'll look at. All right. Now, the first thing it's going to ask me here is I'm going to find what the wattage is. I've got 240 volts times 30 amps. We've already done this calculation. It's just like pi, P time I, or E time I is going to equal 240 volts times 30 amps. They're across from each other. That's going to give you 7,200 watts. We've already done a calculation similar to that. Now, when you get over here and you're looking at the power here, depending on which one you have here, this is what I tell people to remember when I'm looking at power. If you come in and you're looking at applying, say you've got your amperage and resistance, or you have your voltage and resistance. The resistance, when I'm looking at power, is going to be single by itself, but everything else, the amperage and the voltage, you're going to square. Okay?
Right.
So now, if I have the voltage I'm squaring, I'm going to divide it. But if I have the amperage, I'm going to multiply it. Okay?
Right.
And the way I like to look at this, and remember it in this form, this is the way I always think about it on the power, is I go back to the main wheels. So if I look at E time R, E is above R, isn't it?
Yeah.
So naturally it makes sense. I'll square it, but I have to divide into it. I and R are opposite of each other. So they're going to be
Right.
what? Multiplied. Does that make sense?
Okay.
Okay. Every time I look at calculations, and basic calculations, it doesn't deal with code, I'm always looking at a way, how will somebody understand this to where it's easy to understand? And this is
Sure.
one of the main things I look at here is, when do I multiply, when do I divide? Well, and I'm looking at power, that's what I'm thinking. That's something I'd put in my mind a long time ago, is E's above R, so therefore I'm going to square that. And if I have the amperage, I got to square it, but I'm going to multiply it because they're across from each other. Okay?
Sure.
So those are things
Yeah.
to think about.
And the other thing to think about is they do put the wrong answers on the test. So what I like to do is I like to do reverse, where I like to go take the answers and put the answers, plug the answers into the formula, and then see if they make sense for the question.
Right.
You know, but they do put the wrong answers on the test, so you guys gotta watch out for that.
Sure do. Now, you're going to find the watts. You got the voltage and resistance. Now I said E was above R, so I'm going to divide. Now, I couldn't do it in this program here. It wouldn't allow me to put the two superscripted, so I had to just put E2. But you would square here the 240 volts. The 240 volt square is going to give you 57,600 volts, and then I'm going to divide the 8 ohms of resistance in it, and that's going to give me 7,200 watts.
Okay.
Okay? Now, watch this. Here I'm coming in, I'm looking at the same thing. I've got my voltage here, 120 volts. You're going to square that, and then you're going to divide the 186 ohms into that squaring of what your voltage is. And then that'll tell you what your watts are. Okay? Now, here's one where I know the amperage and the resistance are across from each other. So I got 30 amps. I'm going to square that. 30 times 30 is going to give me 900 amps. I'm going to multiply it by 8 ohms. And looky there, what did I get? 7,200 watts like I did before.
True.
Okay? So you're seeing I'm still getting the exact same thing. As I go through all this, you're going to see these wattage values, amperage, resistance, voltage, everything's going to be the same. And you're going to see how all this works.
Oh, nice. David has a clock at work that has that same wheel that you have on that. That's awesome, David. Awesome.
David, I do too.
Well, and David has a good point too. You know that it's possible wrong answers. You just have to know what the right answer is. So,
Sure. And
yeah, that's a good observation, David.
It is true. And, you know, like I tell people, if you'll just start with the basics here and understand how to apply the calculations, you're not going to have as much problem. And I promise you, when I get in and I start doing all the more complex calculations, you're going to see where I'll take some of this stuff we're learning right now and put it in there, and you're going to see it's not that hard. Matter of fact,
True.
uh, you know, when I first started with this, the first thing when I went to work with Dad, he said, I want you to edit. We had a book back then that covered every calculation in the code. I mean, we did x-ray machines, everything. I mean, we got into doing fire pumps and doing all the different things that were required there. We even have the calculation showing you the voltage drop for the fire pump, which is different than a normal voltage drop. And as I was going through it all, I started learning a lot of different little things. And one of the things we'll get to when we get there is I'll have some rule of thumbs I'm going to give everybody to go by. And you're going to see as we go through those rule of thumbs, if you remember this, it's going to make it easier for you during the test. But that's how
I remember it. I remember it.
I know you
like,
do.
It made my test way easy. Like anything that was electrical theory, I smashed it.
Sure.
You know.
And you know, it's just from doing it over and over and over, I learned all this stuff. And it was just because Dad made me learn it. And once I got that part down, then the next thing he told me to do was learn grounding. And we may do a whole grounding series, you know, and then I may get into doing lightning protection for buildings and structures with NFPA 780. And I know everybody would love that because that's something you really got to know what the hell you're talking about when you get into that stuff. But
100%.
This one here, same calculation. You had I and R opposite of each other. So you're going to multiply that. The only difference is you had to square the amperage. Okay. Now, as I look at doing the amperage here, and let me go back one here so you'll see the wheel. Here's my amperage right here on the bottom left-hand side of the wheel. And you're going to see everything looks exactly the same here. Okay. If you look, P is over E. Is that correct? So P is divided into E. E is over R. So R is divided into E. The only thing that happens different here is P is over R, but they're going to take and have you do the whole thing and then square it up at that point. That's the only difference in finding the amperage, but everything is still the same. Okay. And we're sticking with the exact concept that I've been talking about. Okay.
Right. Okay.
Plastic folks. Oh, yeah, that's true.
Wow.
Mm-hmm.
Yeah.
He's right.
Good comment, David.
And those are things that, you know, and David's older like me, you know, and David and I come through in the trade, and I'm sure David went through the same thing when we first started. The first thing they taught us were these basic calculations here. They said, if you don't know this, you can't do the rest of it. And then when we got into doing all of this, and they would tell us about three-phase and single-phase, doing all this stuff. And then they got into voltage drop, and I never forgot 0.866 just because of the three-phase for the voltage drop. And then after that, then they started teaching us the layout of the code, and then we were off from that point on. So now, this is the amperage, and you got the voltage and resistance. It's the same calculation we did at the first. The resistance is going to be divided in the voltage. So 240 volts divided by 8 ohms gives you what? 30 amps. Okay? We've already done this calculation, but the main thing I want to point out, we're still using the same values, aren't we? Same thing.
Yeah.
Hadn't changed anything. Here's the thing. We're pointing there to E divides by R. E is above R. And when you know how to use your Ohm's law and pi formulas, once you know that, then you know how you're going to apply this stuff here. Okay?
Right.
Now, as I go the next one, I'm looking at the amperage again. Here's 7,200 watts, and you got 240 volts. The P is above the E. So 7,200 watts divided by 240 volts gives me what? 30 amps. Okay? And when you get over here, you'll see we got the exact same formula here, P divided by E on the wheel. Once you do that, that'll give you what your amperage is. So anybody working these problems can go back and check this next week.
True.
Now, got one more amperage here, 7,200 watts, and I got 8 ohms. Now, the only thing you're going to do here, you're still going to divide the 8 ohms into the 7,200 watts. The only difference is here, you're going to take and you're going to square root it. So I'll square root the 900 amps, which if I took the 30 amps and squared rooted 30 amps a while ago, what was it? 900 amps. It's going to tell you I equals 30 amps. I should have moved that I down one. When you're working late, I'll tell you. So just remember,
dude, I'm telling you, like you really nailed it tonight, sir. I mean, you've done a good job. This is really good. Like everyone's been giving me compliments.
Oh,
how
really?
much they like it.
Well,
yeah,
thank you.
so,
I appreciate that. I actually, all these illustrations and everything we're showing you and all that, we've put a lot of time and effort into this stuff. And I think when people see the new illustrations that are going to be, and I'll say this will be used in our online training. Now, when we have the online training ready, the only difference between seeing it here and online, the online where those blanks are, you can go up and click those blanks and fill in the values and work the problem. And then I've got in an accordion file underneath that gives you the answers. Now, and one other thing I do is if I have NEC sections and everything, over on the left-hand side of the illustration, there will be standards to review, and I'll have them in order by the steps that you would click to go and check to make sure you're doing it correctly. Oh, thank you, David. I really appreciate that, brother. Now, I'm going to look at the voltage here. So I got 30 amps, and I've got 8 ohms. Well, just like the basic Ohm's law formula, I's across from R, so I'm going to multiply it. So we'll take 30 amps times 8 ohms. That's going to give me 240 volts. Pretty simple to follow, easy to do. Yeah. Same thing here. You'll see we're doing the voltage at the top left-hand side. It's in green. And I times R, there's your formula. Even in the formula requirements, we have it highlighted. And then just multiply that together, and that's going to give you your voltage. Now, the next one I'm going to look at, I know the power. It's 7,200 watts. We know the amperage was 30 amps. So P is over I. So I'll take the 7,200 watts, divide it by 30 amps, and that's going to give me 240 volts. Okay? Nice. Now, as you can see, have I changed any values yet? Not one value's changed, and I'm still getting the same answers that I started with. Now, the other thing that's going to be a little different here is this one out here, and you'll have to remember this for the voltage, is they're going to take and it's not going to be divided here. You're going to multiply on the voltage, okay? The amperage you divide by, but since we're doing the voltage, you want to multiply here, okay? And then you're going to square root it. So you're going to take the power and resistance in this next one, multiply it, and then square root it. But if I was doing it on the amperage, you divide by it because you're going down to a lower value. If you know the voltage has to go, it'll be a higher value. That's why it's multiplied. That's the way to remember it. Okay?
Yeah.
So when I look at this, I've got 7,200 watts of power and 8 ohms. So I'll multiply that. That's going to give me 57,600. Then I'm going to square root it, and that's going to give me 240 volts. Okay? And then when you come over here and you look at the power wheel, once again, same thing I was talking about, P times R, multiply it, square root it, and that'll give you your voltage. So anybody working these problems, you can see we're going to stay. And the great thing is going to be about this, when y'all start doing this in the illustration, you're going to see the same values all the way across. They're just going to be different than what I did in the example problems.
Thanks.
Now, here's where I get into the resistance. Now, basic Ohm's law, I get into this. I actually meant to put a divide sign there on the top one. That should be E divided by I. I did it in step 2. I was working late. So 240 volts is above the amperage, so I'll divide 30 amps into 240 volts, and that's going to give me 8 ohms of resistance. Okay, and then you come over here and you look at this, you'll see I'm going to do that calculation. I divided into E. Once you know those values, fill in the blanks, and that's going to give you your own value. Now, one of the things that you're going to see here is where you come in and you've got the voltage here. Okay. The voltage, if you got the voltage and the power, you're going to square the voltage and divide by the power. If I have amperage here, I'm going to square root the amperage and divide it into the power. Okay. So when you look at this one, you've got 240 volts and you got 7,200 watts. We're going to take the 240 volts, square, it's going to give me 57,600 volts, divide it by the 7,200 watts, and that's going to give you 8 ohms of resistance. Okay. And then you look right here, take the, that's interesting. I've got the wrong illustration there. Let's see. Oh, I've got them backwards. Sorry about that. That's my bad. Yeah. I put them in the wrong spot. So this in here, I'm actually showing it where the amperage, I got them backwards. This was real late at night. Anybody saw my post? I posted like at 3:15 in the morning for the High Voltage Live podcast. That's how late I was up last night getting all this together.
But no, we appreciate it. Like I say, if anybody has any issues, then you can consult the James Stallcup editing team.
It was me. I can tell you who did it. I'll go back and fix that for next week. I'll put that in the right spot. So here you got E squared divided by power. Okay, so that takes care of it. Once you know what that is, do those values, square up the voltage, divide by power, and then that's going to give you what the ohms is. And then the last one that we have here is looking at doing where you know the power, the wattage is 7,200, and you have a current of 30 amps. I'm going to square the amperage, which is going to be 900 amps, divide that into the 7,200 watts, and that's going to give you 8 ohms. And there's your formula right there for finding the resistance. And other than that, that pretty much tonight is where I'm going to finish up.